15 billion miles from where you're sitting right now, a machine built in the 1970s just sent home a signal that should not exist. No warning, no light up. Just a spike in the data that made engineers at NASA's Jet Propulsion Laboratory stop what they were doing and stare at their screens. And here's the part that should unsettle you. Nobody has fully explained it. Not then. Not now. Not after years of trying. Everybody, we need to talk about Voyager 1. Not the highlight reel version. Not the greatest hits story you've heard 100 times about Jupiter and Saturn and the pale blue dot. We're talking about what Voyager 1 is doing right now in a region of space no human instrument has ever touched before, and why the readings coming back from it have scientists questioning things they thought were settled. Let's set the scene first, because you need to understand exactly where the spacecraft is before the anomaly makes any sense. Voyager 1 launched from Kennedy Space Center on September 5th, 1977. Currently hurtling through deep space at 38,000 miles per hour relative to the Sun, or 6 miles per second, Voyager 1 is now some 16 billion miles from Earth, making it the most distant human-made object ever. It finished its original job decades ago. Jupiter, done. Saturn, done. Its early flybys enabled the discovery of things like Jupiter's faint ring system and the detection of volcanic activity on Io, a moon scientists now believe could harbor conditions for microbial life. That was the mission. That was supposed to be it. 4 years, 2 planets, mission complete. That was not it. In December 2018, NASA scientists announced that Voyager 1 had detected the constant drone of vibrations in the ionized gas of the interstellar medium. Think about what that sentence actually means. This spacecraft crossed out of the Sun's protective bubble, the heliosphere, back in 2012, and it kept transmitting. It became the first machine humanity ever built to operate in the space between stars, and it started listening to something we had never heard before. A hum, a constant low vibration in the plasma that fills interstellar space. Scientists expected silence out there, or close to it. They got a drone instead. But that's not the anomaly I'm talking about. That's just the warm-up. In 2020, Voyager 1's magnetometer registered an abrupt jump in the intensity of the magnetic fields embedded in the tenuous interstellar plasma, while its plasma detector measured a rise in plasma density. Sit with that for a second. A sudden, sharp jump, not a gradual drift. Not something explainable by instrument drift or aging hardware. A spike. And here's where it gets stranger. Similar anomalies had been seen before, but the observations had always returned to baseline levels after a period of months. In other words, this had happened once, twice, and each time the numbers settled back down like nothing was wrong. Scientists had a working theory. They called it the piston effect. Researchers believed those transient jumps were generated when surges of plasma streaming outward from the Sun smashed against the boundary of the heliosphere, creating swells that reverberate through interstellar space, compressing interstellar plasma and intensifying its magnetic field. One of the lead scientists on the magnetometer instrument, Adam Sabo at NASA's Goddard Space Flight Center, put it simply. The source is like a piston, he said. The Sun burps. The shockwave travels for over a year through the solar system. It slams into the edge of interstellar space, 15 billion miles from home, and it rattles the environment out there just enough for Voyager to notice. That explanation worked. For a while. Then it stopped working. The anomalies that began in 2020 did not abate, and that led some mission scientists to question whether they originated with the Sun at all. Read that again? The jumps that were supposed to fade away within months, the way they always had before, just kept going and going. Long past the point where a solar shockwave should have dissipated. And that's when a group of researchers who had been comfortable calling this space weather started asking a much less comfortable question. What if this isn't coming from the Sun at all? What if there's something else out there, in a region of space no spacecraft has ever mapped before, that we simply do not have a model for? That is the actual mystery. Not aliens. Not a cover-up. Something arguably more unsettling, because it's real, it's documented, and it is still unresolved. A spacecraft, nearly 50 years old, dying by inches, sitting in a part of the galaxy that has never been directly sampled before, is recording behavior that doesn't fit the models we built to explain it. And Voyager almost didn't live long enough for anyone to keep asking. Because in between these anomalies, this spacecraft nearly went silent for good. And the story of how engineers brought it back is honestly just as wild as the physics. If you're finding this as unsettling as I do, hit subscribe now, because we track stories like this the moment they develop, and you do not want to miss what comes next in this one. Back in 2023, Voyager 1 stopped making sense to its own team. The spacecraft was still transmitting a carrier signal, meaning the connection was technically alive, but the actual data coming through had turned into gibberish. Instead of usable science and telemetry, engineers were getting a repeating pattern of alternating ones and zeros. No information. Just noise dressed up as a signal. For months, NASA's team had no idea what was wrong with a machine they could not walk over to, could not physically inspect, and could only talk to with a message that takes the better part of a day just to arrive one way. Eventually, the team traced the fault to a single corrupted chip in the flight data subsystem, a chip holding a small piece of the code responsible for packaging science and engineering data before transmission. On a spacecraft with this little modern redundancy, that's not a small bug, that's an artery. But here's what should genuinely blow your mind. Engineers could not replace that chip. There's no repair mission 15 billion miles from Earth. There are no spare parts. There's no backup crew. What they did instead was rewrite the affected code and relocate it into working memory elsewhere on the spacecraft, functionally rebuilding part of a computer system from the 1970s, remotely, using a command language most of today's engineers had to relearn from decades-old documentation. And it worked. Voyager 1 came back online, still transmitting, still out there, listening to whatever it is that's rattling the plasma around it. Now here's why the clock on this mystery is louder than ever. Voyager 1 is not just old, it is actively, deliberately being shut down, piece by its own team, just to keep it alive at all. NASA says the twin Voyagers lose about 4 watts of power each year, forcing engineers to shut down heaters, instruments, and other systems in a carefully chosen order. This isn't decay. This is triage. Every single year, the plutonium powering the spacecraft's generators decays a little further, and every single year, someone at JPL has to decide what stays on and what goes dark forever. By April 2026, NASA's status table listed only 2 Voyager 1 science instruments still operating, the magnetometer and the plasma wave subsystem. The cosmic ray subsystem had been turned off in February 2025, and the low-energy charged particle instrument followed in April 2026. Think about what that means. The 2 instruments still running right now on Voyager 1 are the exact 2 instruments that detected the anomaly nobody can fully explain. The magnetometer, the plasma wave subsystem. Everything else has already gone dark. This is genuinely the last window we have. Whatever else is out there in that region of interstellar space, whatever is causing readings that don't match the sun-driven piston model anymore, Voyager 1 has a shrinking number of years, maybe less, to keep telling us about it before those last 2 instruments go silent as well. And the timing could not be more strange, because Voyager 1 is about to cross a threshold no human-made object has ever crossed before. In November 2026, the probe will be 1 light day from Earth. Launched in 1977, Voyager 1 is the farthest spacecraft from our planet, currently exploring interstellar space over 15 billion miles away. NASA has the exact moment marked on the calendar. Around November 18th, 2026, Voyager 1 will be 1 light day from Earth, a light day being the distance light travels in a vacuum in 24 hours. At that moment, the spacecraft will be almost 9 billion kilometers from home. Susie Dodd, the Voyager project manager at NASA's Jet Propulsion Laboratory, described exactly what that means for the team trying to talk to it. If I send a command and say, "Good morning, Voyager 1," at 8 a.m. on a Monday morning, I'm going to get Voyager 1's response back to me on Wednesday morning at approximately 8 a.m., she said. 2 full days, minimum, for a single exchange. No follow-up questions in real time, no adjusting on the fly. Every single command has to be right the first time, because by the time you find out it wasn't, you've lost another 2 days. And this spacecraft was never built for this. Voyager 1 was built with what now feels like ancient technology, but was the best the 1970s could offer. Its 3 computers have just 68 kilobytes of memory between them, and their CPUs run at only 250 kilohertz. To put that in perspective, that is roughly 500,000 times less memory than a basic modern smartphone. Commands sent to the probe are uplinked at a meager 16 bits per second, while scientific data arrives at Earth typically at 160 bits per second. That's about 500,000 times slower than your typical home internet connection. A machine with less computing power than your car key is currently the only thing on Earth capable of directly sampling a region of the galaxy no one else has ever reached. And it is doing it while running on borrowed time, borrowed power, and borrowed luck. Here's where it gets even more interesting, because for the first time in the spacecraft's entire nearly 50-year mission, it is no longer working alone. In September 2025, NASA launched a brand new spacecraft specifically designed to help make sense of exactly this kind of anomaly. It's called IMAP, the Interstellar Mapping and Acceleration Probe, and its entire job is to map the boundary Voyager 1 crossed back in 2012, the edge of the heliosphere, in far greater detail than ever before. IMAP sits at a stable point in space about 1 million miles from Earth, watching the sun's activity in real time and tracking exactly how solar plasma pushes outward toward that same boundary Voyager is sitting beyond. For the first time, scientists have a modern instrument watching the cause, the solar plasma leaving the sun. At nearly the same moment, Voyager 1 is recording the effect, 15 billion miles downstream. If the piston theory is right, if the sun really is the source of these unexplained jumps, IMAP should be able to prove it by matching solar activity to what Voyager records more than a year later when that shockwave finally arrives. And if the numbers don't match up, if IMAP shows the sun was quiet while Voyager still recorded a spike, that is the moment this stops being an open question and becomes a genuine discovery about a part of the universe we have never had a way to observe until now. That is where we actually stand right now. Not confirmed alien contact. Not a hoax. A real, documented, still unresolved anomaly in the only direct measurements humanity has ever taken from interstellar space, recorded by a computer with less power than a pocket calculator, still transmitting from a place no repair crew will ever reach, racing against its own dwindling power supply to answer a question its own instruments raised years ago and never fully closed. And that's really what makes this whole story land differently than most space content you'll see. This isn't a telescope, looking at something billions of light years away and doing the math from a comfortable distance. This is a physical object, built by human hands in a room in California in the 1970s, still out there right now, still working, still recording something that doesn't cleanly fit our best explanation. Every year that goes by, the list of things Voyager can still tell us gets shorter. The magnetometer and the plasma wave subsystem, the two instruments keeping this mystery alive, are living on borrowed power that NASA cannot restore and cannot replace. At some point, likely within the next several years, those final instruments will go dark too, and whatever Voyager 1 was in the middle of telling us will simply stop, mid-sentence, forever. So when you hear that phrase, "we can't explain it," understand what that actually means here. It doesn't mean nobody's trying. It means a team of some of the best scientists on the planet, backed by one of the most sophisticated space agencies in human history, looked at real data from a real place no one has ever measured before, and the numbers didn't add up to anything in the textbook. That's not mysticism. That's the frontier. That's what it actually looks like when humanity runs into the edge of its own knowledge. Voyager 1 is still out there right now as you're listening to this, 15 billion miles away, sending home a signal that takes almost a full day to arrive, still listening to a hum in the dark that we still don't completely understand. It has already outlived its mission by nearly 5 decades. It has already rewritten what we know about the boundary of our own solar system. And it may not be finished surprising us yet. If this is the kind of story you want more of, real anomalies, real data, no filler, subscribe and turn on notifications so you don't miss it when the next update on Voyager comes in. Drop a comment with what you think is really out there past the edge of the heliosphere. And stay close, because this spacecraft is running out of time to answer the question it started asking us years ago, and we are going to be here when it does.